Hey y'all, in this lesson we are looking at a couple more properties of integer exponents. Today we want to be able to write a number with a negative or zero exponent in a different way. So the last lesson we saw different ways to work with positive numbers as exponents. Today we're going to look at negative and zero. So here are our previous properties. The product of powers property basically says when the bases are the same, we add the exponents. The power of products says that if the exponent's the same, but the base is different, then we're going to multiply the bases and keep the exponent. The power of a power says we're going to multiply the exponents. And the quotient of powers property says if we're dividing things with the same base, we subtract the exponents. Our essential question, what do the zero exponent and negative exponent properties mean? In example 1, we're going to take a look at the zero exponent property. Marcella is playing a card matching game with some classmates. 4 matches have already been made, which we can see on the game board. 3 to the 4th is 81, 3 squared is 9, 3 cubed is 27, 3 to the first power is 3. It's Marcella's turn, and she chooses, or turns over, 3 to the 0 power. What card would complete her match? Because 3 to the first is already matched with 3. So what's 3 to the 0? Well, the first thing we're going to do is organize this information on a table. And you'll see this table on your notes. And we know the matches so far. 3 to the 4th is 81, 3 cubed is 27, 3 squared is 9, and 3 to the first is 3. But we don't know what 3 to the 0 is. So what we're going to do is look for a pattern. From 3 to the 4th to 3 cubed, the numbers divide 3. From 3 cubed to 3 squared, the numbers divide 3. From 3 squared to 3 to the first, the numbers divide 3. Well, if we take what we have and we divide by 3 again, we would get that 3 divided by 3 is 1. So we'll fill in the blank on our notes that 3 to the 0 simplified form is 1, and we'll complete the sentence. As the exponent decreases by 1, the product is divided by 3. 3 divided by 3 equals 1, so 3 to the 0 equals 1. Another way to see this is using our quotient of powers property. If we have 3 to the 3rd power and we divide by 3 to the 3rd power, that is how we can take, because we would have 3 minus 3 as the exponent and we would get 0. So that is a way we can see what 3 to the 0 looks like using our rules. And if we also do that out in an expanded form, 3 cubed over 3 cubed is 3 times 3 times 3 over 3 times 3 times 3. That's something divided by that same thing is always going to be equal to 1. So we have, using our quotient of powers property, showing how 3 to the 3rd divided by 3 to the 3rd is 3 to the 0. And we have our expanded view showing that 3 to the 3rd divided by 3 to the 3rd is 1. So 0, or 3 to the 0 power, must equal 1. And the zero exponent property actually states that, you got to write this down next to your exclamation point, it states that anything to the power of 0 is 1, as long as that thing is not 0 itself. So you try these 4 problems. What are these numbers to the 0 power? Hopefully you wrote down 1 for each of these values. Now let's take a look at the negative exponent property. If we're asked to simplify 4 cubed divided by 4 to the 5th, well, we remember that 4 cubed over 4 to the 5th, if we expand that out, we've got 3 of those 4s line up and divide themselves out. So we're left with 1 over 4 times 4, which is 16. So, and then of course we can do our quotient of powers property and take 3 minus 5, and we would get that exponent is negative 2. Okay, so if we did this with our quotient of powers property, we'd get -2 as the exponent. If we did this by expanding it out, we'd get 1 over 16. Now, 1 over 16, 16 is the same as 4 squared. Okay, so we're seeing 4 to the -2 is the same as 1 over 4 squared. So our negative exponent property states, write this down in your exclamation point, that a number to a negative exponent is the same as 1 over that thing but positive. So you can see we start with a to the -n is the same as 1 over a to the positive n. So this is 1 over 4 squared. So we just took that -2, made it positive by putting it in the denominator of a fraction. So write each of these with a positive exponent. What does that negative exponent do? For the answers for these, you should have written down 1 over 8 squared, 1 over 2 to the positive 4 power, and 1 over 3 to the positive 5 power. Our final is to look at, well, what if it's already in the denominator? So we're going to write the expression 1 over 7 to the -3 with a positive exponent. Well, again, we can use that negative exponent property to rewrite 7 to the -3 as 1 over 7 cubed. So we have this like fraction of fractions, 1 over 7 cubed. But we know that we can, when we divide by a fraction, multiply by the reciprocal. So instead of 1 divided by this fraction, we're going to do 1 times 7 cubed over 1. We flip that bottom fraction, and we get 7 cubed. So this is kind of the opposite in that really this negative exponent property just takes wherever that negative exponent is, flip it to the other side of the fraction. If it's on top or a whole number, you're going to put it in the bottom of a fraction. If it's in the bottom of a fraction, you're going to flip it to the top of the fraction and change that exponent to a positive number. Try these two examples to see if you understand. For part A, you should get 5 cubed. And part B, the answer is 2 to the power of 6. All right, to summarize what we've learned this lesson, we can use these additional properties when simplifying or generating equivalent expressions with exponents. Keep in mind, this is when our base is not 0 and our exponent in the negative exponent property is not 0. Okay, so the 0 exponent property says if that exponent is 0, then the answer is 1. And the negative exponent property says that if the exponent is negative, basically flip it to the other side of a fraction and make the exponent positive. Your next steps are to submit your 9.2 notes, complete your build 9.2, and then take your 9.2 mastery check. Good luck.